This is video on kinetics of particles. This is the second video where we are doing problems. In fact, there are going to be quite a few videos where a lot of problems will be there. So this is the first video of on the problems. There is part one where the basic equations are explained. You may want to just have a look at it. Okay. The first problem says a particle of mass 1 kg moves in a straight line under the influence of force which increases linearly with time at the rate of 60 newtons per second. Initially, it being 40 newton. Determine position, velocity and acceleration of that particle after 5 seconds from rest from origin. Okay. So based on this data, if we draw FT curve, it will look like this. You see, initial force is 40. We have started this line at 40. Now, force is mass into acceleration as per Newton's law. So, if I write this force as 1 into A, this essentially actually is AT curve. And once we have AT, acceleration time diagram in place, all these values will be easily able to work out. Now, first is acceleration, which after 5 seconds we can straight away read out as 340. Then velocity, if you refer to videos on kinematics of particle, you will remember that velocity is area under the curve, area under AT graph. So there is a triangle and there is a rectangle. So for triangle, the area is 300 into 5 by 2, and for rectangle it is 40 into 5. There's a rectangle, and for triangle C, this height has been height is 300 and the base is 5, and triangle because it is half. That's why this half comes in. So if we add this up, we get area as 950, which will be the velocity at the end of 5 seconds, and the distance S will be given by moment of area under the curve, moment of area under AT curve about this point. So if we do that, the first area, that is triangle, divided by 5 by 3, because this area centroid will be at 5 by 3 from here. So it is multiplied by 5 by 3 and we get this quantity, and here we take this area 40 into 5 and multiply by half of 5, that is 2.5. So we are essentially finding moment of this area of the triangle about this point and moment of area of this rectangle about this point. We add it up, we get 1750 as distance S, or position from the origin. Okay, look at the second problem. It says a vertical lift of total mass 750 kg acquires an upward velocity of 3 meter per second over a distance of 4 meter, moving with constant acceleration starting from rest. Calculate the tension in the cable. Take G as 10. So what we do is we draw this free body of this lift or elevator. Now we have taken G as 10. So in free body we have the weight and the tension. Now we apply Newton's law here. Force is into mass into acceleration. Motion is in vertical direction. So this law will be applied as a scalar equation in the vertical direction. Now see, the net force in vertical direction is T minus 7500. And as per Newton's law, it should be mass into acceleration. Now here we want to point out one thing. There is a reason why this T is taken as positive and 7500 as negative. See, because we are calculating, see, we are told that this body is moving up. So that's the direction of acceleration A. So we want force in that direction, and therefore T minus 7500 will be upward force. There will be, that will be equal to the mass into acceleration. So since the motion is upward, we have taken all upward forces positive and downward as negative. So T minus 7500 is equal to 750 A. Now one more information is given, that it acquires an upward velocity of 3 meter per second over a distance of 4 meter. So we'll apply our formula v square is equal to u square plus 2s, in which we'll put 3 vs3 initial velocity as 0 and work out a. And this a we'll put it here to get the value of t which was asked. Really straightforward problem indeed this is. Okay, next. It says an airplane has a mass of 25,000 kg and its engine develops a total thrust of 40 kilonewton along the runway. The force of air resistance to motion is given by d is equal to 2.25 v square, where v is velocity in meters per second and d is in newtons. Determine the length of the runway required if the plane takes off and is airborne at the speed of 250 kilometers per hour. So see, Newton's law says force is mass into acceleration. Writing this acceleration as dv by dt and then dividing and multiply by dx, we get it as m dv by dx into dx by dt, and putting dx by dt as v, we get force as m dv by dx into v. The force is given 40,000 minus 2.25 v square. So that is equal to, as per Newton's law, mass 25,000 v dv by dx. And this we separate the variables and integrate. Now you see this 240, if I convert it to meter per second, it comes 66.6. So when velocity changes from 0 to 66.6, at least the runway has to be that long, because at this speed is going to be airborne. So we integrate this, and what we get then is x is equal to answer of this integration, which will come to 1600 meters. Thank you.